Okay, so we're scooting on. We're going to talk about the quadratic formula. Now, the quadratic formula is another way of solving those second-degree equations. In a previous lecture, we talked about completing the square to solve them. And prior to that, we talked about factoring. This is a third method of solving a quadratic or a second-degree equation. Now, the generic form of a second-degree equation looks like this. ax squared plus bx plus c equals 0. If I'm solving for x, then my coefficients are a, b, and c is that constant. Are you with me? Okay, so now the quadratic formula looks like this. I am solving for x, and what I need you to notice is that x is actually in the middle. Okay, so x equals, I always refer to it as the opposite, or you can just say the negative, same thing, the opposite of b. So if b is positive, it's going to be negative. If b is negative, then it will be positive because you've got an extra negative sign in front of it. Remember that. So I call it the opposite of b plus or minus the square root of b to the second minus 4 times a times c, the whole thing over 2 times a. This is the quadratic formula. Now, I promise you, they didn't pull this out of the thin blue air. They actually took this generic form and completed the square on it. And when they did, this was the result, believe it or not. So, I promise, we didn't pull this out of the thin blue air. Are you with me? Okay, so, couple of things to notice. One, you need to make certain that the equation you're solving is equal to 0. Secondly, you need to make sure that it's in descending order. Ax squared first, the x to the first power second, and then the constant last. Good? Okay, so let me put a problem up here and let's you and I solve this. Okay, so I would like to solve this using the quadratic formula. Now, remember what we mentioned. In order to use the quadratic formula, we have to make certain of two things. One, that it's set equal to 0, and secondly, that it's in descending order. Which I see neither one here. I need it equal to 0. So, and by the way, I always suggest that your second degree variable, the number in front, I suggest it always be positive, okay? So, this 8 is in front of the y squared, and that 8 is already positive, which means I want to leave this here. So what I'm going to move to the other side is this 5y, and since this is a positive, you're going to subtract 5y from both sides. Are you with me? Okay, and now I'm going to simplify this. So 8y squared, right, in descending order, minus 5y minus 3. Are you with me? Okay, so I have it equal to 0, and I have it in descending order. This is a requirement if I'm going to use this formula. Now, in the formula, I have a, b's, and c's. So I need to identify what my a, b's, and c's are in this particular quadratic equation. So, a is the coefficient of x squared, isn't it? Well, that means 8 is equal to my a because it's the coefficient of y to the second. With me? Okay. B is the number in front of x. Well, the number in front of my y to the first power is negative 5, so I am going to let b be equal to negative 5. And lastly, c is just the number. It's the constant. It doesn't have the variable with it. So in this case, my c is equal to a negative 3. Are you with me? Okay, so now I need a little bit of board space. so that I can do some of the work that we need to do. So hang in there a second. Let me get rid of some of the stuff on this side. I'm hoping you wrote this formula down because we're going to need it. I know I have it remembered in my brain. And you use this enough, you'll have it remembered in your brain also. I guess that word should have been memorized, right? Okay, so anyway, regardless, let's take a look at this. So the quadratic formula says that I'm basically solving for that variable in the middle, which means I'm solving for this y. So we're going to have y equals. Now remember the formula. It said negative b. So I'm going to put a negative sign, and then I need to write the value for b. Well, what's my value for b? Good, negative 5. And then the formula says plus or minus the square root of b to the second. What's my b again? Yep, negative 5. So it's negative 5 to the power of 2 minus 4 times the value of a, which in our case is 8, times the value of c, which in our case is negative 3. And the whole thing is over 2 times a. This is the formula. I am just plugging my numbers into the formula. I'm not doing anything else at this point. I'm just plugging these numbers in. Okay, so let's do some simplifying. So I still have y equals, now what's a negative in front of a negative 5? What does that make it? Good, it makes it positive. Plus or minus the square root. What's negative 5 squared? Excellent, 25. Minus. Now I've got to multiply 4 times 8, or I should say a negative 4 really, times 8 times negative 3. I've got my answer. You do your work. What do you get? I'm hoping you got 96. Yes? Okay. All over 2 times 8, which is, excellent, 16. Now, y equals 5 plus or minus the square root. 25 plus 96 needs to go next, right? What do you get? Good. 121. All over 16. Excellent. And then y equals 5 plus or minus the square root of 121. What's the square root of 121? I'll wait. Good, 11. And the whole thing is still over 16. Are you with me? Okay, now, it looks like I'm going to have 2 answers. And I should have 2 answers because I have a second power there, don't I? That tells me I should get 2 answers. So one answer is going to look like y equals 5 plus 11 all over 16. And the second answer looks like it's y equals 5 minus 11 over 16. Okay, so in this particular case, 5 plus 11, good, 16. 16 divided by 16, 1. Excellent. So there's one of my answers. The second one, 5 minus 11, good, negative 6 over 16. Which means I'm going to have to reduce, aren't I? Yep, so y equals negative 3 over 8. So there is one answer, and there is a second answer. Cool? So, if you looked at this problem, and when you put it in descending order and set it equal to 0, and if you're like, oh my gosh, I don't remember how to factor that, well, then you can use the alternative. You can use the quadratic formula instead of factoring, and you get the exact answers that you would have gotten had you factored. So, this is an alternative to factoring. With me? Okay, hang in there. Got a couple more problems for you. Okay, so I'm back. So let's look at this particular problem, and let's solve it using the quadratic formula. Remember, you have to make sure 2 things are in place before you use the quadratic formula. You need to make certain that it's equal to 0, which it is, and you need to make certain that it's in descending order, which it is. And then after you do that, you need to be able to identify your A, B's, and C's. So remember, when it's in descending order, it's extremely easy to identify. A is your lead coefficient. It's the number in front of the squared variable. B is your number in front of the variable to the power of 1, which in this case is negative 12. And C is equal to, good, 9, which is the constant. With me? Okay, so look at your formula. Hopefully you wrote it down. We have, remember, we're solving for the variable in the middle is really what it turns out to be. M equaling negative. And then we write down B, and our B is negative 12. Plus or minus the square root of, that's right, B to the power of 2 minus 4 times A times C. And the whole thing is over 2 times A. With me? Okay, so we plugged all our numbers into the formula. Looks like we have some simplifying to do. M equals, negative in front of a negative makes it, good, positive. So this is positive 12 plus or minus the square root. What's negative 12 to the power of 2? Excellent, 144. And then you have to do 4 times 4 times 9. Go ahead, you figure it out, I'll wait. I know what I get. Good. You get 144. All over 2 times 4, which is, good, 8. Well, that square root's going to turn out to be pretty nice, isn't it? So I have M equal 12 plus or minus the square root of, 0. All over 8. Now, you're still supposed to get 2 answers. With me? That square tells me I'm supposed to get 2 answers. So when I take a look at this, I'm looking at M equals 12 plus or minus, what's the square root of 0? Good, 0 all over 8. Correct? Okay. Which means one of my answers is M equals 12 plus 0 over 8. And the other is M equals 12 minus 0 over 8. Agreed? All right, well, 12 plus 0 is clearly, 12 divided by 8. And what's 12 divided by 8? What does that reduce to? They didn't ask me for decimals, so stay off those calculators. Good. You divide both of them by 4. So this reduces to 3 over 2, doesn't it? And this second one, 12 minus 0 is still 12. So I still have 12 over 8, which means my second answer is the exact same as my first answer. You with me? Okay. So, what do you think? Not too bad? Cool, hang in there. Got another problem for us. Okay, so let's look at this problem. Again, I'd like to solve it using the quadratic formula. So, 2 things to remember. First, is it equal to 0? In this case, the answer is yes. Secondly, is it in descending order? And again, the answer is yes. So we're good to go here. So you need to identify your A, B's, and C's. Remember, A is the number in front of the variable that's squared. So in this case, A is equal to, good, 1. There's an imaginary 1 here, isn't there? B is equal to the number in front of just X, which in this case is negative 5. And C is equal to a negative 4, the number without the variable, right? Okay, so look at your quadratic formula. Hopefully you have it written down. And let's see what it looks like when we plug it in. So, in this case, it's x. X equals negative. And then I write the value for b, which in this case is a negative 5. By the way, b is not always negative, so just hang in there. Don't go, hey, is b always negative? No, it just happened to be that way in these problems. So plus or minus the square root of b to the second minus, what's the rest of it? Good, 4 times a times c, all over 2 times a. With me? Okay, looks like we have some simplifying to do. X equals, now that's going to be a positive 5, isn't it? Plus or minus the square root of, good, that's going to be 25 plus 16, won't it? All over just 2. And I'm going to continue this over here. So it looks like x equals 5 plus or minus the square root of, good, 41 over 2. So, question for you. Can you take the square root of 41? Yeah, 41 is not a perfect square, but 41 is also prime, which means I can't even break it down, which means if I can't take the square root of 41, I can't do 5 plus that number or 5 minus that number. And they didn't ask me for a decimal. So believe it or not, this would be your final answer. Now remember, how many answers are you supposed to get? Yeah, you're supposed to get 2 answers, aren't you? You're supposed to get 2 answers. So technically, if you split it up, one answer is 5 plus the square root of 41 over 2. And your second answer is 5 minus the square root of 41 over 2. You with me? Okay, you can leave it this way, or you can split it into 2 answers so you can see it better for yourself. So in this particular case, the answer is not very nice, but here are my 2 answers. Cool? Okay, got one more problem for us to work on, so hang in there. Okay, so let's look at this 4th problem. Again, I'd like to solve it by using the quadratic formula. So 2 things. It must be equal to 0 and it must be in descending order. So in this case, it's not equal to 0, is it? So that means this minus 9 has got to move over. Do you agree? So we need to do what to make the 9 go to the other side? Good, you need to add it, which means you're going to end up with 5m to the second plus 2m plus 9 equals 0. So now it's equal to 0. Is it in descending order? Yes, it is. Good. So can you identify your A, B's, and C's? Yes, you can. So I'm hoping that you can identify your A, B's, and C's by now. Good. A is equal to 5. B is equal to a positive 2. And C is equal to 9. Are you with me? All right. So plug it into the quadratic formula. M, that's what I'm solving for. M equals negative, and then I write the B. In this case, B is just 2. Plus or minus the square root of B to the second minus 4 times A, which is 5, times C, which is 9, right? All over 2 times A. Does that make sense? Good. Okay, let's keep simplifying. M is equal to a negative 2 plus or minus the square root of, whoops, you know, I was a little bit ahead of myself there, wasn't I? Because it's supposed to be B squared, isn't it? Well, B is what number in this case? Yeah, B is 2. My brain was already jumping ahead of itself. See, this is why I need you to do the work with me. So 2 to the second. And 2 to the second is, yep, 4, which is what my brain already knew. It was jumping ahead. Okay, so 4 times 5 is, good, 20. 20 times 9, good, 180. All over 10. So far, so good? All right. I'm going to bring it up onto this side of the board. So M equals negative 2 plus or minus the square root of, Yeah, that's a negative 176 on the inside, isn't it? All over 10. Huh, you're taking the square root of a negative number, aren't you? Okay, you need to remember how to do that, right? All right, so I'm going to carve out some space right here for myself. The square root of a negative 176, first off, pull the negative 1 apart from the 176, right? Okay, and this is going to be an I, isn't it? Good. Now 176 you need to break down. So I'm going to let you do the breaking down of this, but what I'm noticing is, or what I got was basically 16 times 11. And the square root of 16 is, good, 4. And 11, I have no idea. Okay, so I'm ending up with 4i times the square root of 11. Cool? All right, which means this next line is looking like m equals negative 2 plus or minus 4i times the square root of 11 all over 10. You with me? Okay, so you need to verify this, that the square root of 176 for yourselves, okay? I know most of you will take my word, but some of you are going, but how did you get that? Break the 176 down. Do our little factor tree, right? Keep doing your factor tree. 2 times what? 88. Keep going and see that you would pull out a 4 and an 11 stays underneath. Okay, so now this is a fraction. I cannot do negative 2 plus this I square root. I can't even minus it. But what I am noticing is this. I have a 2, and the number outside the square root's a 4, and I have a 10 down here, right? They're all even numbers, aren't they? Couldn't I reduce these even numbers? All right, so remember, the only way to cancel a fraction like this is to have multiplication. So I'm noticing that a 2 goes into both terms in the numerator. So if I factor out the 2 from the numerator, I'm left with negative 1 plus or minus, 2i times the square root of 11 all over 10. With me? Now I've got multiplication on top, and the multiplication on top will allow me to cancel. So I'm going to cancel the 2 with the 10, which is going to now leave me m being equal to negative 1 plus or minus 2i square root of 11 over 5. And I still have two answers here, don't I? Because I have negative 1 plus this over 5, and then negative 1 minus this all over 5. I still have two answers. I was supposed to get two answers because that's what that tells me. You with me? Okay, so this one was actually a really good problem. Not only did you use the quadratic formula, but then you had to remember how to take the square root of a negative number. So we had some work to do. And then you had to remember how to simplify this fraction when there's an addition or subtraction problem in the numerator. You need to turn it to a multiplication problem in order to do any canceling, which we did. With me? Okay, hang in there. I got another concept for you. Okay, so let's look at this concept known as the discriminant. Now here's the thing. The discriminant is part of the quadratic formula. As a matter of fact, it's what is under the square root of the quadratic formula. Under the square root of the quadratic formula was b squared minus 4ac. Now, here's the deal. If this number under the square root is a perfect square, that makes life easy for us, doesn't it? We can just take the square root of it, we get a very nice answer, no problem. But if the number under the square root is not a perfect square, yeah, things don't look so nice, right? Okay. So we did 4 examples, and each of those 4 examples is going to be associated with what I'm going to write up here. All right? Now, The discriminant will tell me how many answers I'm getting, and it will tell me what kind of answers they are. Since this is part of the quadratic formula, you are clearly going to get how many answers? Correct, 2. You will always get 2 answers, right? It's just, what do they look like? Are they real numbers? Are they imaginary numbers? Are they perfect squares? Are they not perfect squares? What are they? So let's start talking about one of the possibilities of the discriminant. If my discriminant is less than 0, which means the number under the square root is less than 0, correct? So here's what I need you to do. I need you to look and see which problem that we just did, which of the 4 problems we just did had this number under the square root being less than 0, had it being negative. Yeah, that was problem number 4. Problem number 4 had the discriminant, the number being less than 0. So help me out. How many answers did I get? Good. We got 2 answers, didn't we? And were these answers real answers or were they imaginary answers? Correct. You had an I in it, didn't you? So, by the way, these answers are distinct. Distinct meaning they are different from each other. They were not the same answer. So I had 2 distinct answers and they were imaginary. With me? Okay. Now, what happens if our discriminant was actually equal to 0? Okay, so go look back in those previous 4 problems that we did and tell me which problem had the number under the square root being equal to 0. Good, that was problem number 2. Problem number 2 had the number under the square root being equal to 0. Okay, so help me out. How many answers did I get? Yes, I still got 2 answers. Were they real answers or were they imaginary answers? Yeah, they were real answers. There was no I in them, so they were real answers. So I still got 2 real answers. But these answers were the same, weren't they? They were duplicates, right? They weren't distinct. They were the same, weren't they? Okay, so here is how some of the authors of the book will phrase this. And I'm just going to put in parentheses duplicate so we remember. But here's how some of the authors of the book will phrase this. Some of them will say, this is one possibility. Some of them say one real answer because they're like, well, it's a duplicate. So, you know, technically I only have one real answer. Okay. Other authors of the book will say you've got a double root and it is real. Double means 2 of a kind. With me? Okay. So, what happens if our discriminant, b squared minus 4ac, is greater than 0? Which problems did we just do where we had b squared minus 4ac greater than 0? Yeah, that was problem number 1, right? And that was problem number 3, wasn't it? Agreed? Okay, I'm going to check my work to make sure I am saying that correctly. Yep, that was problem number 1 and problem number 3. Okay, so let's look. In problem 1 and problem 3, how many answers did I get? Good, I got 2 answers. Were they real answers or were they imaginary answers? Yes, they were real answers. So here's the deal. Regardless of which number, I had 2, and by the way, were the answers the same or different? Good. So I had 2 distinct real answers or solutions. Now, in problem number 1, I had a perfect square, didn't I? Okay, so problem number 1 had a perfect square, wasn't it? Under the square root, the discriminant was a perfect square, wasn't it? Because it was a perfect square, they'll call these two distinct real answers, they'll call them rational. Now, problem number 3. That's the one where we got that square root of 41, wasn't it? So problem number 3, it was not, right? It was a non-perfect number, non-perfect square. That's the one where we have the square root of 41 under it, correct? Okay, so because it wasn't perfect, it's still two distinct real answers, but because it wasn't perfect, they will now be considered irrational answers. So the 4 problems we did fit into these categories. If it's less than 0, I get 2 distinct solutions, but they're imaginary. If it's equal to 0, there's 3 ways of saying it, okay, and they all mean the same thing. I get 2 of the exact same answer. If it's greater than 0, I'm going to get 2 real answers, 2 distinct real answers. If that discriminant is a perfect square, they're rational. If they're not a perfect square, they're considered irrational. Cool? Okay, hang in there. I've got some applications for us. Okay, so let's talk about some applications of the quadratic formula. So let's take a look at this. It says the base of a triangle is 12 more than twice its height. If the area of the triangle is 45 square centimeters, find its base and find its height. So I don't know about you, but this looks like a geometry problem. Why? Because I'm dealing with a triangle and it talked about the area of the triangle. So what do you think is the first thing you should do? Yeah, I suggest drawing it. So it says the base of the triangle is 12 more than twice its height. So I have got a triangle, and here is the base of it. Here is the height of it. Okay. By the way, I cannot assume this is a right triangle because it didn't say anything about a right triangle, so don't go there. But it said the base is. So the base equals 12 more than. What's the more than mean? Good, addition. So I'm going to add the 12 to something. What am I adding the 12 to? Twice the height. So 2h. And what do you think I'm letting h represent? Yeah, h is representing the height. And what else did they tell me? They said the area of the triangle is 45 centimeters squared. Cool? Okay, so let me go over here onto our scratch work and redraw the triangle. We have the base is equal to 2h plus 12. This is h, this is our height, right? And they told me the area equals 45 centimeters squared. So now, help me out. Since it's a geometry problem, since I'm talking about a triangle, and I'm talking about the area, what do you think you need to know to start this problem after you've drawn it? Yeah, you need to know the formula, don't you? You need to know the formula for the area of a triangle. So, area of a triangle equals base times height divided by 2. In case you had forgotten that, there it is. So, time to fill in the blanks, so to speak. So, area, good, that's 45. The base is 2h plus 12. The height, well, that's just h, all divided by 2, isn't it? Good. Now, from here you can proceed a couple of different ways. So me personally, in the right side, I don't want to deal with those parentheses. So I'd rather get rid of that parentheses and distribute. And when I distribute, I would get 2h squared plus 12h. wouldn't I? Good, excellent. And then I've got this fraction, and I'm noticing that I've got a bunch of even numbers over there on the right side. I've got a 2 on top, I've got a 12 on top, and I got a 2 on the bottom. They're all even, aren't they? So what do you think we can do? If you said reduce, I'm agreeing with you. So, but remember, in order to reduce, you can't have an addition problem. You cannot have an addition problem. You need a multiplication problem. So in the numerator, I'm noticing that I can factor out a 2. Whoops. And when I do that, hopefully, things will look a little nicer. Yep, those 2's will cancel, won't they? So I'll be left with 45 equaling h squared plus 6h. Agreed? Good. All right, so in order to solve the second degree equation, what do you need to do? Excellent. You need to set it equal to 0, which means in this particular case, I need to subtract the 45 from both sides. What do you think? With me? Okay, so this looks like a problem that we solved just a little bit ago, right? We use the quadratic formula. So let's use the quadratic formula again. Maybe this factors, maybe it doesn't. So let's check it out. I am noticing my A is equal to, good, 1. By the way, it's equal to 0 and it's in descending order, so I can actually find my A, my B, and my C. And let's plug it into the formula, and now let's see what we get. So I'm solving for h, and that's going to be equal to negative. And then I get to write the b, which is 6, plus or minus the square root of b, which in this case is 6, squared, minus 4 times a, which is 1, times c, which is 45. Oh, excuse me, you know what I meant. See, this is why I need you guys working with me. C is a negative 45, isn't it? Which means 4 times 1 times a negative 45, all divided by 2 times 1. Good? Okay, so let's keep working on this. Let's keep simplifying it. H equals negative 6 plus or minus square root of, what's 6 squared? Good, 36. So I have a negative times another negative, right? Yep, that's going to give me positive. And 4 times 45. I'll wait. Good, 180. All over 2. Did this make sense? Are you guys with me? Loving it. Okay, so keep going. You combine what's under that square root, don't you? So I have h being equal to negative 6 plus or minus the square root of, good, 216 all over 2. So is 216 a perfect square? Yeah, no, I didn't get it to be 1 either. So let's see. You know what I forgot to check? Would they be okay with an answer that's a decimal? So let's go back. Oh, no. They said use radicals as needed. They didn't want you to give them a decimal. All right, so back to our work. So I am going to have to look at that 216. And since they don't want a decimal, I have to see if I can break down that 216. So I'm going to do my work over here. Let's see, 2 would go into that, right? How many times? That's right, 108. And let's see, another 2 goes in there 54 times. And another 2 goes into there 27 times, and I just ran out of space. So you know what? Let's try that again. And in actuality, I'm going to go back over here because I've got more room. So we're breaking down that 216. Let's try that again. We said 2 goes into there 108 times. 2 goes into here 54 times. 2 goes into here 27 times. Oh, now I got a 3 and a 9 and another 3. Okay, so, woof, lots of stuff here. So what am I looking for again? Yeah, I'm looking for a square root, which means I'm looking for how many of a kind? I'm looking for 2 of a kind. So I'm seeing 2 2's. So I got the square root of 2 squared. Here's a single 2. I see 2 3's. And then I see a single 3. Okay, so 2 to the second. Square root of 2 to the second times the square root of 2 times the square root of 3 to the second times the square root of 3. So here comes a 2, right? And here comes a 3. Do you agree? And I'm left with a square root of 2 and a square root of 3, aren't I? So I can multiply the 2 and the 3 on the outside and get 6. And since both of these are square roots, I can multiply them together, which gives me square root of 6. Break this down. Remember to break this down. So what I am seeing is h is equal to negative 6 plus or minus 6 square root of 6 all over 2. All right, so do you notice in the top I can factor out a 2? And I'd be left with negative 3 plus or minus 3 square root of 6, wouldn't I? And you're like, why'd you factor out a 2? So I could cancel it with the 2 on the bottom. So my height is equal to negative 3 plus 3 square root of 6, or my height would be equal to negative 3 minus 3 square root of 6. 2 answers. But you're looking for the height of a triangle. Is the height of a triangle allowed to be negative? Good, it's not. Which means this second answer is not going to work for us, is it? This answer right here is not going to work for us. Agreed? Okay, this one is out because it's negative. I have a negative minus another number, so that's not going to work. So this one is gone. Now, this one right here, I got to make sure that that turns out to be a positive number. Even though they say, you know, no decimals, I still need to make sure it's positive. And yes, when I literally do this work, I end up with a positive number. So we're good there. Okay? All right, so just found the height. The height is equal to negative 3 plus 3 square root of 6. Got it. But now I also need the base. And the base is going to be 2 times the height plus that 12. All right, so let's see. Negative 6 plus 6 square root of 6 when you distribute the 2, right? Plus the 12. This first 2 terms is what you get when you distribute that 2. And now I'm seeing like terms. I'm seeing a negative 6 and a positive 12, which will give me a positive 6 and then still plus the square root of 6. With me? Okay, so found the base, found the height. Not necessarily the nicest looking answers, but there's your height and there's your base. And centimeters squared, squared means area because you did base times height, which means this is just in centimeters and this would just be centimeters. Cool? Okay, lovely answer, right? But so be it. If they want radicals, that's what they get. All right, let's look at another one. A waterfall has a height of 1,500 feet. A pebble is thrown upward from the top of the falls with an initial velocity of 16 feet per second. The height of the pebble, and the height of the pebble is known as h, and it's in feet, after t seconds is given by this equation. They want to know how long after the pebble is thrown will it hit the ground. Okay, so here's the deal. You know, they gave us a lot of information, but which information is relevant and which of it is fluff? They gave me the height of the waterfall was 1,500 feet. Great. They said that they threw the pebble up and it had initial velocity of 16 feet per second. Great. But you know, they gave me this equation, and in the equation is the 1,500 and the 16 feet per second. So I'm grateful they gave me those first two sentences, but they wrapped it up nice and neat for me in this equation. So I'm a happy camper. Now, let's look at the actual question. The actual question is how long? If they're looking for how long, that means they're looking for which variable? Good. That means they're looking for t, because how long means time. So we're trying to find t. After the pebble is thrown, will it hit the ground? If it hits the ground, that means it's on the ground. That means that's the height of the pebble, isn't it? Hitting the ground means we're talking about the height of the pebble. And if the pebble is on the ground, well, what's its height if it's actually sitting on the ground? Yeah, if it hit the ground, that's 0 feet. Which means my h is equal to what? Yeah, your h is equal to 0. Cool? Okay, so let's do some work on this other side. Here was the equation they gave us. I want to make sure that was a plus. Okay. The pebble is on the ground, which means your height is 0, because there's no distance between the ground and the pebble. And they want us to find time. All right, we can do that. Do you notice you have a second degree equation? Which means you could either factor this or you could use the quadratic formula. Now, some of you may be asking about completing the square. You know, I wouldn't do it. You could, but I wouldn't do it. It's not going to be so nice. All right, so here's the deal. One of the things I would like to try to do, if possible, is I would like to try to make these numbers a little bit smaller. Can I make them smaller to work with? Because if I can make them smaller, then the numbers will not be so large inside that quadratic formula. All right? So the one thing that I noticed that I could do is I could divide all of these by 4. All of these would reduce by 4. And if I do it to the right side, I must do it to the left side. Now, 0 divided by 4 is still what? Good, 0. So that makes our life easier. By the way, do you remember what I mentioned in my lecture a little bit ago? Do you want that number in front of t squared to be positive or negative? Yeah, you want it to be positive. So you know what? I'm going to divide by a negative 4. Why? Because I want that negative in front of the t squared to be positive. All right, so negative 16 divided by negative 4. That's right, positive 4. Positive 16 divided by negative 4. That's right, negative 4. And positive 1,500 divided by a negative 4. Yeah, that's a negative, and I got 375. So hopefully we're in agreement. All right, now I'm going to go back here just a second because I want to verify. They said type in integer or a decimal. They're allowing me to have a decimal in this case, rounded to the 10th place. So just trying to get a feel for it because I know I'm going to use the quadratic formula. And you need to identify once it's equal to 0, once in descending order, you need to identify your A, your B, and your C. Okay, let's see what you get. I'm going to start filling these in. I'm solving for t. So t is equal to negative b plus or minus square root of b to the second power minus 4 times a times c all over 2 times a. Cool? All right, it's looking like we have calculator work to do. So let's take this slow, make sure we're all on the same page. This 4 would be positive, plus or minus square root. Well, negative 4 squared. Good, 16. Now, I technically have a negative 4 times a positive 4 times a negative. Yeah, that's going to give me positive. So you're going to have to do your work on multiplying while I do my work on multiplying. And I ended up with 6,000 when I multiplied those numbers. Did you? Hopefully so. Okay, let's continue some work over here. So I have got t being equal to 4 plus or minus the square root of 6,016, all divided by 8. Remember, they're allowing us to use a decimal. So I am allowed to find the decimal of 6,016. And how many places will you round it to? Yes, you will round it to 1. So you do your work, I'll do my work, and I ended up with 77.6 all over 8. Cool? Okay, so I have 2 answers now, don't I? I have t being approximately equal to 4 plus 77.6 over 8. And I have t being approximately equal to 4 minus 77.6 all over 8. Okay, you do your work, I'll do mine. Hopefully we come up with the same thing, right? Got to do 4 plus the 77.6. And then you have to divide it by 8. And I got 10.2, so hopefully we agree. And on this other one, we have to do 4 minus the 77.6 and then divide by 8. So I got a negative 9.2. So, question. T stands for what in our problem? Yeah, it's time. Is time allowed to be negative? No. So there goes that answer. Which means in this case, my time is going to equal to 10.2. Do you remember what your units are? That's right, there it is, seconds. .2 seconds. Good? You with me? Okay, got another one for you. A holding pen for cattle must be square and have a diagonal length of 100 meters. So, I really don't care about the 2 questions A and B until I figure out what the little blurb is telling me that I just read. So, a holding pen for cattle must be squared. So, you know what square means. So, I've got a square, right? And when you have a square, what are some of the things you know? Right. All 4 sides are equal. So, I'm just going to call this S. I'm going to say this side is just S, which means all of these sides have the same measurement. They're all S, right? Good, because it's a square. And all 4 corners are right angles, aren't they? Because it's a square. Agreed? Okay. Now, this holding pen, that's a square, has a diagonal length of 100 meters. So I'm hoping that you remember what it means to have a diagonal. Corner to corner, this will be 100 meters. Huh. Gee, what does this look like as soon as they put in that diagonal? I mean, I know it was a square, but as soon as I put in that diagonal, am I still dealing with a square? No, you're not. You're dealing with a what? Yeah, you are dealing with a right triangle, aren't you? And what always goes along with a right triangle? Try to remember a couple lectures ago. Yep, that Greek guy. The Pythagorean Theorem, which is a squared plus b squared equals, good. So I am going to go on to a new slide here. So we have more room to work. This is S, this is S, this is 100. We said we have a squared plus b squared equals c squared. Which do you have to remember? Which one do you have to identify correctly, the A, B, or the C? Good, the C. The C is the most important. Remember, the C represents the hypotenuse. And in a right triangle, the hypotenuse is always across from the 90-degree angle, which means in our case, C is equal to this 100. With me? Coming back to mine? Okay, so I don't care which one of these A and which one of these B. In this case, they're both the same anyway, so it doesn't matter. But if they were different, it still doesn't matter. So we have A squared plus B squared equals, good, C squared. And we have 2S squared equals, yep, that's 10,000. You're solving for S, aren't you? So what's the first thing you're going to do? Excellent. I'm hoping you said divide both sides by 2, because that's what I would have said. So I have S squared equal to 5,000. Wonderful. And I'm hoping, will they allow us to use a decimal? Let's go take a peek. Nope, they said use radicals. They didn't want a decimal. All right. You know as well as I do, you've got to take the square root, don't you? So we take the square root on both sides. By the way, you're going to get how many answers? 2. One of these will be S equaling positive square root of 5,000. And the other one will be S equaling negative square root of 5,000. So question before we go any further, S stands for the side of this triangle. Is the length of that side allowed to be negative? No. So you go bye-bye that answer. So the only answer I really care about is S equaling the square root of 5,000. And they won't let me use a decimal. So I'm going to have to break down this 5,000. And hopefully I can pull some kind of perfect squares out of it. So let's go do our work. I've got room over here. Let's break this 5,000 down. 5 times 1,000. Do you agree? 1,000 would be 2 times 500, yes? This would be 5 times 100, yes? This would be 10 times 10. Agreed? Okay, so here's what I'm seeing. Remember, square root means 2 of a kind. So I see 2 tens. I see 2 5s. And I see 1 2. So I'm seeing this rewritten as S equals 10 squared times 5 squared times 2. And since there's multiplication between them, as we have discussed before, you are allowed to look at the square roots separately. And so I have 10 times 5 times the square root of 2, which is equal to 50 times the square root of 2. And my meters. So they wanted to know the length of one of the sides. We just found it. Here's the answer to part A. Part B wants the area of the pen. Okay, so how do you find the area of a pen? Oh, the pen is a square, right? The pen is a square. So how do you find the area of a square? Good. It's just length times width, isn't it? All right. So hopefully we have left ourselves enough room. So part B, the area is going to be equal to length times width. Well, since it's a square, the length and the width are the exact same number, aren't they? Okay, so I can do 50 times 50. Yep, 2,500. Square root of 2 times square root of 2. Good, square root of 4, which means 2,500 times 2. Ooh, I got that 5,000 back again. Sounds a little coincidental. By the way, meters squared, because this was meters and this was meters. And m times m is m squared. All right, what do you think? Not bad, right? Okay, got one more problem for you. By the way, this problem was really good. I liked this problem. Why? Because it made you actually realize that even though they gave you a square to work with, that you were really dealing with a right triangle, which means you really had to work with Pythagorean's theorem, which means after you dealt with Pythagorean's theorem, you had to take the square root of this lovely number and you had to remember how to break it down. And then you had to remember how to multiply square roots in part B. This problem had a lot going for it, so it's a really good problem. All right, let's look at this last problem. The Souls live on a corner lot. Often children cut across their lot to save on walking distance. The diagram to the right represents the corner lot. The children's path is represented by this dashed line. Approximate the walking distance that is saved by cutting across their property instead of walking around the property. So here would be them walking around the property. So I guess that means in order for us to figure that out, we'd have to know what x is, huh? Okay, but you see what this is a picture of? Yep, it's a picture of a right triangle again, isn't it? And if it's a right triangle, then what do I think of? Good, I'm thinking of Pythagorean's theorem again. And since I'm dealing with Pythagorean's theorem again, I have to remember the theorem. Yep, a squared plus b squared equals c squared. And which one of those do I have to identify correctly, the a, b, or the c? Good, you have to identify the c correctly, because the c is the hypotenuse, which is always across from that 90-degree angle. Yes? Okay, so I'm going to let my a be x. I'm going to let my b equal to x plus 4, and c is equal to 20. Cool? Okay, so let's go to the next page, and let's look at the work we need to do. So we said a squared plus b squared equals c squared. We said a was x. We said b was x plus 4. And we said c was 20. Okay. This is x squared. Uh-oh. X plus 4 times x plus 4. I got some side work to do. Because this means I need to write this out twice. So I can multiply it correctly. Because if I don't multiply this correctly, my answer is going to be completely off. Remember, addition and subtraction act like super glue. this addition sign between the x and the 4 does not let me look at the x separate from the 4, which is why I had to write that out twice and get x squared plus 8x plus 16. And 20 squared, yep, I knew some of you already on your calculators figuring it out. Okay, so collecting some like terms, 2x squared plus 8x plus 16 equals 400. Okay, now, some of you may be asking yourself at this point, now what do I do? Well, I'm going to tell you. There's a key here that tells me exactly what I've got to do, and that key is this square. That square tells me to finish solving, you're going to have to factor. And if you have to factor it, then instead you could use the quadratic formula. So the choice is yours. But either way, you have to make sure it's equal to what? Yeah, it needs to be equal to 0 before you can do either of these. Before you factor or before you use the quadratic formula, you must make certain it's equal to 0. Good? Okay, which means I need to move that 400 over, which means I'm going to get 2x squared plus 8x minus 384 equaling 0. Okay, so, you know, I would rather be dealing with smaller numbers. And gratefully, I'm noticing that all of these will divide nicely by 2, which means I have to do the same thing to the other side. So I've got x squared plus 4x minus, what do you guys got? I know some of you figured it out. Good, 192 equals 0. And now I can either factor it or use my quadratic formula. I'm going to choose to use the quadratic formula. Why? Because I do not want to figure out 192. So, gratefully it's equal to 0. Gratefully it's in descending order, which means A is 1, B is 4, C is negative 192. So, let's see what the formula looks like. And I'm solving for x, aren't I? So x is equal to negative b plus or minus the square root of b squared minus 4 times a times that c, all over 2 times a. Okay, so all I'm doing now is working on my arithmetic, really, if I think about it, because I have to do 4 squared. And then I get to multiply these numbers. But you know as well as I do, those two negatives are going to give you a, those two negatives are going to give you a positive, aren't they? So when you do the multiplication, you end up with, good, same thing I did, 768, all divided by 2. Let's see. And x would be equal to negative 4 plus or minus the square root of, good, 784 over 2. Okay, 784, is that a perfect square? Yeah, some of you are like, I already tried it. It is. It's 28. Yay! Good, we don't even have to deal with decimals. We don't even have to look back and see if they said use decimals or radicals. So, 2 answers now, don't I? One answer is x equaling negative 4 plus 28 all over 2. And the other answer is x equaling negative 4 minus 28 over 2. So let's see, on this one, what would we get? Add those, you get 24, right? Divided by 2 is 12. Add these, you get a negative 32 over 2, which is negative 16. Huh. What was x? Yeah, X was the length of the side, wasn't it? X was the length of that side. So is my answer allowed to be a negative? Nope. I did everything right, but I can't use that answer. So in this case, my X is going to be equal to 12. So if X is equal to 12, that means this other side is going to be 16, isn't it? All right, so remember what they said, right? Remember the question they're asking. Approximate the walking distance that is saved by cutting across the property instead of walking around the property. So if we redraw this picture, this is 20 feet, right? Now notice the X side is 12. The X plus 4 side is 16. If the children walked around the property, that means they would be walking 28 feet. Agreed? But if they cut across the property, they're only walking 20 feet, right? So, know what you got to do? Excellent. You have to subtract, which means they saved 8 feet. They're walking 8 less feet by cutting across the soul's property versus walking around it. Now, if the souls are okay with that, yay. But if they're not, those kids are going to have to learn to walk around and walk another 8 feet every time they take that path. I guess they'll get their steps in for the day, won't they? Anyway, hope this helps. I'll catch you on the flip side.